So here's something I learned today about our um, brother Speedio machines. So we used to have a Haas mini mill, and the Haas mini mill had rigid tapping. And if you look at the specs of the rigid tapping, it says you can rigid tap up to 2,000 RPM. And because we were conservative, we always just used a rigid tap at 1,500 RPM or 1,000, no, 1,000 RPM, because it made the math easy, and we could verify that the tapping speeds were all correct. So the Speedio supports the standard um, tapping can cycle, but it has these more optimized can cycles now. They just say they're better. Exactly how much better they are, I don't know. Not going to get into that. Um, we've been using our Speedio for, let's see, 7 months, and we've been rigid tapping using the G77 cycle. And because we were still just being conservative and we weren't really in a hurry, we were running at 1,500 RPM. Now, the Speedio can rigid tap up to 6,000 RPM. And I was talking to an applications engineer today and talking about some things. And he said, oh, well, make sure you use these extra commands if you're going to tap that slow. You have to put it in a slow tapping mode. And that was kind of caught me by surprise. And so I just wanted to talk about these slow tapping modes, so to speak, and that's really what I want to do. So we're going to look at our post real fast, and I just want to show you what's going on in our post. So what I ended up having to do is actually create, so here's this G77 Brother Tap Inch. This is what we were using. So let's go and have a look at that real fast. So there's this M19 code. The M19 code is something that performs essentially an orientation before you start tapping. So that allows you to retap back into the same hole. So we just post M19s always because that way it's easier for us if we ever decide we have to retap a hole halfway through a part. Who knows? We can rehit the part. We can rehit those tapped holes without any trouble. So it basically synchronizes the tap to a specific clock start position. And then we've got G77. Z is the depth that we have to tap to. And J is the pitch of the tap. S is the spindle speed, and then R is the retract plane. So J is the pitch. Now, if you provide the G77 with a J parameter, J is an inch parameter. So if it's a 440 thread, 440 tap that you're using, then you would provide a 40 for that pitch. So it would be J40 when it posts out. Now, when we use metric taps, G77, okay, ignore the other stuff for the moment. We've got G77Z, which is the Z depth, and now we've got I pitch, and the I parameter is the metric pitch in millimeters. So if it's an M10 by 1.5 millimeter tap, then you would have I 1.5 is what you would provide. So this is the metric G77 can tap routine that's brother specific. But now let's talk about these speeds, these slow speeds. So there's the brother metric 1,800 RPM to 6,000 RPM. That's fine. You don't need to use any of the slow speed additives, so to speak. But if you want to tap under 600 RPM, then you need to be here. If you want to tap between 600 to 1,200 RPM, you want to use this guy. And I say use this guy. I made all these for this morning. Okay, but let's just go look. So if we go look at the under 600, you're supposed to run an M241 here before the tapping cycle, and you cancel it with an M250 at the end. If you're running between 600 and 1,200 RPM, you want to run an M242 here at the start before the tapping cycle. And again, you cancel it with the M250. If you're running 1200 to 1800 RPM, you run an M243, and again, you cancel it with the 250. So because I was tapping metric this morning, I made these 4 entries, and they're all correct. And what I'm going to do at some point soon is I'll just copy this brother tap inch 4 times, and I'll make the same 4 canned cycles for the inch tap. And the only real difference between the inch and the metrics are the inch has a J parameter for the inch pitch, which is the number of turns per threads per inch, and the metric has an I parameter, which is the number of millimeters per turn. So let's just see this in action real fast. So we'll just cancel out of here, cancel out of here. So I just dropped a hole here, and it's a diameter. Oh, I don't want to save the file because it's just a temporary file. So it's a diameter 315, which is close enough to M10. Okay, so let's just go and do a quick tapping operation. We're not going to do any spotting or anything else. We're just going to do the tap. So let's just do the tap. Okay, so let's just say the material top is at 0, and let's go pick our. Oh, I said we were just going to do the tap. So let's remove the drill and let's add the tap. Okay, so we're going to add a tap operation from our tool changer. So here's taps, and we're going to pick the metric tap, which I think is, here it is, 303, 315, blah, blah, blah. Okay, so this is, it's an M10 by 1.5 millimeter pitch tap. And so there's a 1.5 here in the tap pitch. Now, this library is kind of all messed up. And the reason this library is all messed up is because I started it when we had our mini mill. And the mini mill, it wants the pitch in thousandths. So for a M4 tap, then sorry, an M4.07, 0.07 is this many thousandths of an inch per rotation. So the I guess one way of thinking about it is that the Haas operates on the I parameter of the Speedio, but in inch, not metric. Okay, so anyway, let's not get too confused there. So you can see here I've got these brother inch taps and the 32. So there's a 1032 brother tap and an 832 brother tap. In the pitch, I've just got 32s. And here's a metric brother tap, and in the pitch, I've got 1.5 because that's a 1.5 thing. And all of these weird decimals, just ignore those because those are all taps that I had from the Haas days, and eventually I'll just remove those or rename them in my library or edit them and fix them as I go. And that's why I put the word brother here in the descriptions to remind me that these ones are brother and these ones are not. So I'll fix that. So here's a couple of 440s for brother, and here in the pitch it's 40. And what I have to do is I have to remember that if it's an inch tap, I use the inch profile in the can cycle, and if it's a metric tap, I use the metric profile. But let's just stay focused. Okay, so here we are. Let's pick this M10 tap, and let's go pick some steel material because let's just pretend this is steel. So let's just go grab probably this one here. I think that'll probably work. Oh no, okay, that didn't work because it wasn't set up right. So let's go pick another one. It's I can't remember what kind of tap that was, but anyway, let's just go and make it work. Steel. And this is, because I tend to make things overly complicated. Let's just pick the steel up to 80 ton, whatever that is. Okay, so it picked 472 RPM spindle speed and a feed rate of 700 inches per minute, which is Oh, sorry. Okay. So we kind of got to ignore these feed rates in this dialog because the the can cycle ignores this stuff. So we'll just see what happens when we post it out. So let's just say yes. We're going to go through 1.2 inches deep, and we're going to pick here our can cycle. So the let's go back. The RPM is 472, so we're in the slowest mode, so it's under 600 RPM. And we click finished, and we'll click finished. And now let's just post this out real fast. Post. And let me just move that over there. And here we go. Okay, so here's our post. So we're using this metric tap 1.5 and tool 0. Yada yada. Okay, here we go. So here is the G77 brother tap metric under 600 RPM. So we set M241 for the slowest mode, and then we do G77, Z depth, I because it's a metric pitch of 1.5 millimeters. There's our spindle speed. There is our retract plane, and basically then G80 cancels the tap cycle, and M250 cancels the slow speed cycle. So so that's how this works. So if you're doing speeds under 600 RPM, then you need to be in M241. If you're doing speeds from, I think it was 600 to 1200 RPM, you need to be in M242. And if you're doing 1200 to 1800, you should be in M243. And if you're over 1800 RPM and below 6000, then you don't need a special M code because it's already in the correct mode. And then at the end, you need to cancel it with an M250. So that was something I learned today, and I just wanted to make sure that other people, if they do search on the internet, can find this information in an easy format. I chose to modify my post because it's fairly easy for me to do post mods in this program 1CNC. But if you choose not to modify your post, then you just have to add these values into the NC code, or have this as some kind of custom code that posts out at the beginning and at the end of the tapping cycle. Alrighty, well, I hope that was helpful.